And if time allows us, we're going to also revise on the Newton's rules of motion. So we're going to take questions, and then we're going to go through the questions and discuss each of the questions. We start with the linear motions. We start with the linear motion. I'm going to pick a few questions which we are going to discuss. Some of these questions that we are going to discuss are similar to the ones that we did in the end of term exam, where many students did not do very well. So allow me to share a document here. Allow me to share a document here, so that we can go through the document together. I'm going to share a document. There we are. We have that question there. The question read that the figure below shows a velocity time graph shown there for a motion of a certain body. And the first question there is that describe the motion of the body in the region OA. Describe the motion of the body in the region OA. Then you have the region AB, and then we have the region BC. So this is a body that is under motion, and therefore we need to understand what is happening between the regions OA, AB, and BC. So the region OA, here we say that the body is moving in constant acceleration. It is body is moving in constant acceleration. You can say that the body is under uniform acceleration. Say body moving with constant acceleration, or the body is moving the uniform acceleration, or you can even say that the body is moving with increasing velocity. You can say that the body is moving with increasing velocity, or the body is moving with constant acceleration, or you can even say it's the motion is uniform acceleration, constant acceleration, or even body moving with increasing velocity. So in the region AB, the body is moving with non-uniform. The body is moving with non-uniform, decreasing velocity. As you can see, if you look at the curve, you look at the graph, it is a curve. It is not a smoother, it's not a straight line. And therefore, we say that the body is moving with uniform, decreasing velocity. The body is moving with non-uniform, the body is moving with non-uniform, decreasing velocity. You can also say that the body is moving with decreasing acceleration. The body is moving with decreasing acceleration, as you can see that from our curve between A and B. You can see the body tends to kind of decelerate. Therefore, you can talk about non-uniform deceleration. You can also talk about non-uniform deceleration. Non-uniform deceleration. Then between the point B and C, between the points B and C, between the points B and C, you can see very well that the body is moving with constant velocity. Constant velocity. Or you can say that the body is moving with zero acceleration. Body is moving with zero acceleration. As you know very well that acceleration is given by change in velocity divided by time. It therefore means that the change in velocity is zero, because the initial velocity is equal to the final velocity. And therefore, we say that the body is moving with constant velocity, or the body is moving with zero acceleration. For the fact that initial velocity is equal to final velocity, therefore change in velocity is equal to zero, meaning that acceleration is also equal to zero. Therefore, we say that the body is moving with constant velocity, or the body is moving with zero acceleration. Hope you are there. Then part B, this is where you are supposed to do some calculations. Question is asking us, a car moving with initially at 10 meters per second decelerates at 2.5 meters per square second. Determine number one, its velocity after 1.5 seconds. So what should come into our mind is that talking of decelerate, talking of a body which is decelerating, in this case it is a car which is decelerating, it means that the acceleration is negative. So in this case, question number B Roman 1, we are required to calculate its velocity after 1.5 seconds. Therefore, we need to ask ourselves, which equation do we use here, so that we can be able to determine the final velocity, because the final velocity is what's being asked here. So we use the equation V is equals to U plus AT, where V is what we are calculating, the final velocity. We have our U as 10 meters per second. We've been told that the car is usually moving with initial velocity 10 meters per second. And then the acceleration is deceleration, which is negative 2.5 meters per square second. And the time that it is taking, it's 1.5 seconds. Therefore, it follows that V is equal to 10 into bracket minus 2.5 multiplied by 1.5. That is going to give you 10 minus 3.75. 10 minus 3.75. Therefore, the final answer there is 6.25. 6.25 is your final acceleration. 2.25 is 6.25 is your final. It's your final velocity. So for the second part, the question is asking you to determine. The question is asking you to determine the distance traveled in 1.5 seconds. The distance traveled in 1.5 seconds. In this case, we are going to use the second equation of linear motion. We're going to use the second equation of linear motion, which is S is equal to U T.
Mr. William?
Yes?
Listen, can you use classic, if you want to use a whiteboard, use classic whiteboards.
Okay. Let me choose my whiteboard. Let me choose my whiteboard. I can see you are also writing on my whiteboard from the other end. Me take the.
Just go to share. Don't
Okay.
use whiteboard direct. Go to share.
Share.
When you press share, there is screens. There is document. When you press document, you'll see whiteboard classic.
I'm using a mobile phone.
What? Yeah.
I'm using a mobile phone. So I may not be able to use the classic whiteboard.
Yeah, because the other one, the student will be lighting on it.
I can see they are writing on it.
Yeah.
Okay, I have seen the classic one. I have seen the classic. It's okay. It is in order. So sorry for the disruption. We are in question number B. Question number B2, where you are asked to determine the distance traveled by the car in 1.5 seconds. Here I have said that we use the second equation of linear motion. We use the second equation of linear motion. Which says that S is equals to UT, UT plus a half AT squared. So in our case, we know that U is equals to 10, A is equal to negative 2.5, T is equal to 1.5. Therefore, it follows that if you substitute accordingly, you're going to see that you're going to get that the distance that's going to be covered after 1.5 seconds is actually 12.1875 meters. But remember, in physics, we say that we express our answers in four significant figures, and therefore our answer is 12.19 meters. However, even the 12.1875 is also acceptable, but it is advisable that we express our answers into four significant figures. Alternatively, you can use the third equation of linear motion, which says that v squared is equal to u squared plus 2as, where s is the distance traveled or covered by the car. So making s the subject, you're going to have v squared minus u squared divided by 2a. Therefore, if you substitute accordingly, we're going to have our v, which we calculated at our previous question, that's question number Roman 1. We found that the final velocity is 6.25. Therefore, if you substitute accordingly, you're going to have 6.25 squared minus 10 squared. That is going to give you the same answer. If your arithmetic is in order, you are going to get the same answer. So let us move to the next question. Let's move to our next question. That's question number Roman 3. Question number Roman 3. Question number Roman 3. Here, you are required to calculate the time taken for the car to stop. You are required to calculate the time taken for the car to stop. In this case, the time taken for the car to stop, it means that the final velocity at this time, is going to be 0. Because we are told here that this is the time taken for the car to stop. So when the car stops, it means that the final velocity, v, is equal to 0. Therefore, from the equation v is equals to u plus at, we can be able to calculate t. From the equation v is equals to u plus at, we can be able to calculate the time taken. So we know our v is 0. We know that v is equals to 0. We know that u is equal to 10 meters per second. We know that a is acceleration. We've been told that the car is decelerating, therefore it's negative 2.5 meters per square seconds. Therefore, it follows that 0, which is v, is equals to 0. Therefore, 0 is equals to 10 minus 2 t. 0 is equal to 10 minus 2.5 t. 2.5 t. But what we need is t. Therefore, we will have to take 2.5 t to the other side of the equal sign. Therefore, it's going to be 10 is equal to 2.5 t. Dividing through by 2.5, you divide through by 2.5, going to get your t as 4 seconds. Going to get your t as 4 seconds. Therefore, the time that the car takes to stop is actually 4 seconds. Is actually 4 seconds. Then question number 2, Roman 2. Question number Roman 2. You are being asked to sketch. Question is asking you to sketch. Sketch. Question is asking you to sketch the velocity time graph for the car up to the time the car stopped. Sketch the velocity time graph for the car. Sketch the velocity time graph for the car up to the time the car stopped. Sketch the velocity time graph for the car up to the time the car stopped. So before you even sketch, you need to ask yourself, how does it look like? You know very well that you've been told that the car is decelerating. Probably after the driver applies brakes, the car is going to decelerate and finally come to a stop. And therefore, you need to have in your mind the shape of the graph of a decelerating moving body. So in this case, if this is the Cartesian plane, then it means that the graph is as such. Graph is as such. Therefore, need to show that it is initially at 10 meters per second. This is velocity time graph. Therefore, it is at 10 and decelerates up to 0. So it is as such. Then the next question is asking you to calculate the distance. Calculate the distance that is from the graph. Determine the distance the car traveled before stopping. We know that the area under the velocity time graph, gives us the distance covered by the moving body. The area under the velocity time graph gives us the distance covered or the distance traveled by the moving body. In this case, we have a regular shape. The graph under the graph, the area under the graph, it is forming a regular shape, which is a right angle triangle. Therefore, you know from mathematics that the area of a triangle is given by a half base multiplied by height. Therefore, it follows that the area under our graph is going to be given by a half base times height. Our base is 4, our height is 10. That is a half multiplied by 4 multiplied by 10. That gives us 20 meters per second. I mean 20 meters because it is distance. 20 meters. This is the distance. This is the distance. This is the distance the car traveled before stopping. And I have said that from the graph, we usually obtain it by basically determining the area under the curve. So let's move to the second question. Question number 2. Let's move to question number 2. Question number 2. Question number 2 is asking us about the constant force that opposes the motion of a stone initially at rest as it falls through air from a tall building. So this is a stone that is somewhere on top of a building, a tall building, and it is released. Therefore, it's going to fall down. This is it's going to undergo free fall. But at the moment when it is undergoing the free fall, it is going to oppose some form of force. And basically, this is the updraft force due to air. This is the updraft force due to air. This is the updraft force due to air, which acts in the upward direction. Therefore, this stone is going to, it must overcome the updraft force. So for instance, if we know the magnitude of the updraft force, therefore we can be able to actually know the amount of force that is opposing this particular motion. If we know the magnitude of the updraft force of air, we will be able to calculate the force that is opposing the motion of the stone that is undergoing the free fall. So this is the force that is opposing the motion of the falling stone updraft due to air. Let's move to question number, next question. Let's move to the next question. This is the third question. That question is about a particle from rests and accelerates uniformly in a straight line. After 3 seconds, it is 9 meters from the starting point. Determine the acceleration of the particle. Determine the acceleration of the particle. Determine the acceleration of the particle. So this question goes beyond the linear motion. This is a question that goes beyond the linear motion, and you need to input the knowledge of the Newton's laws of motion. So from the second Newton's law of motion, we know that F is equal to ma. From the second Newton's law of motion, we know that F is equal to ma. We know that F is equal to ma. But you can still use the knowledge of because we are being asked about to determine the acceleration of the particle. We can still employ the equations of linear motion. You can still employ the equations of linear motion. Being told that the particle is from rest, therefore the initial velocity is equal to 0. U is equal to 0. It accelerates uniformly. After 3 seconds, we know after 3 seconds, 3 seconds is the time that is taking to move a distance of 9 meters from the starting point. Therefore, we can use the second equation of linear motion. We can use the second equation of linear motion to determine the acceleration of the particle. The second linear equation of motion states that S is equal to ut plus a half. S is equal to ut plus a half at squared. What we need is A. Therefore, we need to make A the subject of the formula. We need to make A the subject of the formula so that we can be able to proceed. So we know that S is equal to ut plus a half at squared. We need A. Therefore, we'll have S is equals to. Therefore, we'll have S minus ut. S minus ut is equal to a half at squared. We'll have S minus ut, S minus ut is equals to a half at squared. But we need a. What we need is a. What we need is a. And therefore, we will need to divide through by a half t squared. Therefore, equation becomes a is equals to s minus ut divided by a half t squared. Divided by a half t squared. The rest is substitution. We substitute for the values. We know that s has been given as 9 meters. U is 0. U is 0. T is 3 seconds. Therefore, A will be given by 9 minus 0 because we have 0 multiplied by 3 is going to give you 0. Therefore, it's 9 minus 0 divided by a half multiplied by 3 squared, which is a half multiplied by 9. Therefore, acceleration will be given by 9 divided by 4.5. Therefore, acceleration will be 2 meters per square second. 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 Let's move to the next question. Let's move to the next question. So every time you do calculations in physics, kindly remember to write the units. Remember to write the units because you can have the right answer, you can have the correct answer with no units. There is no mark for that. You can have the correct answer with the wrong units. There is no mark for that. Some of you have been coming to us complaining about marks which they did not earn. You must be able to understand that at this age, you must use the correct guidelines. Therefore, whenever you do calculations in physics, remember to include the correct units. Include the correct units because correct answer with no units, there is no mark for that. And also a correct answer with wrong units, there is no marks for that. So the next question is about particular figure. This question is almost similar to the one that was in the end of term exam. That the figure below shows a graph of velocity against time. The figure below shows a graph of velocity. A graph of velocity against time. A graph of velocity against time. Describe the motion of the body during the 10 seconds. Describe the motion of the body during the 10 seconds. So looking at the graph, you can see that this is a body that is undergoing deceleration. The body that is undergoing deceleration. The body that is undergoing deceleration. Therefore, you can say that the body moved with uniform decreasing velocity for the first 5 seconds and then reversed with uniform increasing velocity for another 5 seconds. The body moved with uniform decreasing velocity for 5 seconds. Then the motion was reversed with uniform increasing velocity for another 5 seconds. Or you can say that the body decelerated uniformly for 5 seconds. The body decelerated uniformly for 5 seconds and then reversed the motion, then revert with uniform increasing velocity for 5 seconds. The body decelerated uniformly for 5 seconds, and then reversed with uniform increasing velocity for another 5 seconds. Or you can say that the body decelerated with uniform, the body decelerated uniformly for the first 5 seconds, and then reverse with uniform acceleration for the next 5 seconds. The body decelerated uniformly for the first 5 seconds, and then reversed with uniform acceleration for another 5 seconds. Another 5 seconds. Let us move to another question here. Move to another question here. That's a ball of 20 grams is thrown vertically upwards with a velocity of 5 meters per second. The air resistance is 0.4 newtons. In this case, what we are calling air resistance is friction due to air, is 0.4 newtons. Determine the net force on the ball as it moves upwards. Determine the net force of the ball as it moves up. Take acceleration due to gravity G to be equal to 10 meters per square seconds. So in this case, you need to apply the knowledge of the Newton's law of motion. From the second Newton's law of motion, you know that F is equal to ma. From the second Newton's law of motion, you know that F is equal to ma. But the force that we are referring to here will be as a result of the mass of the body, and therefore we know that mass produces a force called weight. Due to its mass and the gravitational acceleration, the gravitational force G. So in this case, the force that we need here will be as a result of the mass of this body, which is 0.2 kilograms, multiplied by the gravitational force G, which is 10. Therefore, the net force of the ball as it moves upwards will be 2 newtons. But we'll be told that it's going to overcome air resistance. It's going to overcome air resistance, which is a frictional force of a magnitude 0.4 newtons. Therefore, the net force F is going to be 1.6 newtons. This is the net force of the ball as it moves upwards. Remember, as it moves upwards, it has to overcome the air resistance or the friction due to air. Therefore, we need to also consider that. So by subtracting the force that it is overcoming, the net of force of the ball as it moves is 1.6 newtons. 1.6 newtons. Question number 2, from what I had said previously, that from the second Newton's law of motion, we know that F is equals to ma. We know that F is equals to ma, and therefore it follows that acceleration is going to be given by force divided by mass. It follows that it follows that the acceleration of the ball is going to be given by the net force of the ball as it moves upward divided by the mass of the ball. The net force of the ball as it moves upward, the net force of the ball as it moves upward divided by the mass of the ball. That is 1.6, as we have calculated previously. We found that the net force of the ball as it moves upwards is 1.6 newtons because it has to overcome the resistance due to air or the frictional force of the air or the frictional resistance of the air. And therefore, to get the acceleration of the ball, we need the net force. We divide it by the mass of the ball. And this is 1.6 divided by 0.2. This is going to give us 8 meter per second. 8 meter per second. That is acceleration of the ball. Then we have the maximum height reached. The maximum height reached by the ball. Remember, as the ball moves upwards, it reaches a point where it can no longer overcome. It can no longer overcome the gravitational force which is acting in the opposite direction. Therefore, it reaches a point that it can no longer move upwards. And therefore, at the point where the final velocity of the ball becomes 0, that is a point we call the maximum height reached by the ball. So we need to know behind our mind that at that point, V is equals to 0. V is equals to 0. Because at this point, the ball starts moving downwards. The ball starts moving downward. Therefore, to calculate the maximum height, we can use the third Newton's law of motion, which says that V squared is equals to U squared minus 2AS. Why are we saying minus? Because in fact, it's minus 2GS, minus 2GS. Because the ball was moving upward, therefore it was moving in the opposite direction of the gravitational acceleration. And therefore, we say that V squared is equals to U squared minus 2GS. Therefore, S is what we need. Therefore, S is going to be given by, remember we have said that U is equals to 0. We know that V is equals to 0 because it is the point where the ball reaches the maximum height. It cannot move any longer upwards. And therefore, it starts moving down. Therefore, at that moment, the final velocity V is equal to 0. Therefore, our equation changes to S is equals to U squared divided by 2GS, where G is, in fact, it is S is equals to U squared divided by 2G, where G is the gravitational acceleration, and U is the initial velocity. U is the initial velocity, and therefore it follows that the initial velocity of the ball had been given as 5 meters per second. Therefore, 5 squared divided by 2G, that is 25 divided by 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 25 divid 25 divided by 20 is going to give us, can do the calculation and see what it's going to give us. That is 25 divided by 20. That is going to give us, that is 5 over 4. That is 1 point. Let's do the calculations. 25 divided by 20 is going to give us 1.25 meters. 1.25 meters. Going to give us 1.25 meters. Go to the next question number 24. Number 24. A stone is thrown vertically upwards. A stone is thrown vertically upwards. A stone is thrown vertically upwards and reaches a height of 100. It reaches a height of 100 meters. Reaches a height of 100 meters. A stone is thrown vertically and it reaches a height of 100 meters. It reaches a height of 100 meters. The questions here are: calculate the initial velocity of the stone. Again, this is a similar question. This is vertical displacement. Therefore, the stone has to overcome gravity. And therefore, to calculate the initial velocity of the stone, we are going to use the third equation of vertical displacement. The third equation of vertical displacement, which is v squared is equals to u squared minus 2gs. We want u, but we know that upon reaching the maximum height, upon reaching the height of 10 meters, the height of 10 meters, we consider the height 10 meters, 100 meters as the maximum height. Consider it as the maximum height h, and therefore it means at this point v is equal to 0. It means at this point v is equals to 0. Therefore, if v is equals to 0, it follows that u squared is equal to 2gs. It follows that u squared is equal to 2gs. U squared is equal to 2gs. And by substitution, we know that g is 10 and s is 100. Therefore, u is equal to the square root of 2 multiplied by 10 multiplied by 100. Therefore, u is equal to the square root of 2000. The square root of 2000, which is equal to 44.72 meter per second. 24.72 meter per second. 44.72 meter per second. Then the second part of this equation, this question, the second part of this question is asking us to calculate the total time for the stone. Determine the total time. The total time the stone is in air. So in this case, we are going to use the third equation going to use the third equation of vertical displacement, which is S is equals to ut minus a half gt squared. In this case, S is equals to 0. In this case, S is equals to 0. Therefore, T, if we make T the subject when the displacement is equal to 0, if we make T the subject when the displacement is equal to 0, we are going to find that T is going to be given by 2u. T is going to be given by 2u over g, 2u over g, where g is the initial velocity u, which we had calculated earlier, and g is the acceleration due to gravity. Therefore, the total time in air will be 2 multiplied by 44.72 divided by 10, which is going to give us 8.944 seconds. It's going to give us 8.944 seconds as the total time in air, as the total time in air. That will be the total time in air. I hope we are together. We are walking this journey together. I want us now to move to some other questions. And see how we can go through them. Need to go to some other questions. Let's do some questions under Newton's law of motion. Let's do some questions under Newton's law of motion. But before we go there, in the exam that we did, the end of term exam that we did, I'm hoping that there was that question number 14, where you are supposed to analyze the graph of velocity time graph for a motorcycle, where you're supposed to calculate the displacement of the motorcycle, and then you also required to calculate the total distance covered by the motorcycle. So for the displacement, we usually calculate the area under the curve. That is before the motion is reversed. Therefore, we calculate the area under the curve on the positive side and the area under the curve on the negative side. Then we subtract the two. Because when the motion is reversed, then it means that it is going to move in the opposite direction, and therefore the displacement will be the difference between the distance covered by the body before the motion is reversed. I mean the difference between the distance covered by the body and the distance covered when the motion is reversed. But the total distance covered by the motorcycle is actually given by the area under the whole graph, So again, on the first part of that question, on the first part of question number 14, in the analyzing the graph on question number 14b, you also need to observe what is happening. For example, the nature of the motion between U and V. You can see very well that there is no change in velocity. That is, the body is traveling with constant velocity. or you can say that the body is moving with zero acceleration, because acceleration is given by change in velocity divided by time. So in this case, there is no change in velocity, and therefore the acceleration is equal to zero acceleration, because there is no change in velocity. Between V and W, you can see that this is constant acceleration, or you can say it is uniform acceleration, or you can say that the body is accelerating uniformly. So you need to make such observations. Then from W to X, this is non-uniform deceleration. That is non-uniform deceleration, or varying deceleration, or decreasing deceleration, decreasing non-uniform deceleration, or the body is decelerating non-uniform. All those terms are acceptable. So in physics, we need to choose our language wisely, because you can say something, can mention a term which will be converse to what you are expected to say. So let us move to the Newton's law of motion. Under Newton's law of motion, we have three laws. Under the Newton's law of motion. And the examiners will rarely ask us to define the laws, but they bring in calculations and maybe questions where you will be required to explain a certain occurrence. And therefore, if you do not understand the Newton's law of motions, therefore it becomes very difficult for you. To answer the given questions. And I have, through my own observation, I have realized that there are many students who are yet to understand these two topics. Therefore, now, because you are at home, you need to revise on these areas. So under the Newton's law, we have three laws. One of them is the law of inertia. You know what it states, that a body remains in state of motion or rest unless acted upon by external force. That one you know. You know that the second one is about the rate of change of momentum of a body is directly proportional to the resultant force producing the change, and it takes place in the direction of that force. Then, of course, the third one is about the third law. You know, the third law is about the action and reaction. You know, the third law is about the action and reaction. And under the second law, this is where we have the impulse and all that. So I would want to pick a few questions. I'd like to pick a few questions under this topic. And also in your holiday assignment, there's a question. There's a question under what we have just discussed. Therefore, you need to go through it. And remember, it's going to form 80% of the opener exam. So I'm hoping that you're also revising the holiday assignment, because if you are not, then maybe it is going to cost you when it comes to the end of, to the opener exam. So allow me to share something here. About the Newton's law of motion. Allow me to share. So there we are. Want us to discuss this part. Want us to discuss these questions. Want us to discuss these questions. We have the figure below shows a lorry towing a trailer using a rope. We have a lorry towing a trailer. A lorry towing a trailer using a rope. We have a lorry towing a trailer using a rope. The lorry exerts a force N on the trailer, and the trailer exerts an equal but opposite force M on the lorry. The frictional force between the two, the frictional force between the trailer and the road is F. And the question here is, the question that's being asked here is, explain how the force M, N, and F, explain how the force M, N, and F enables the trailer to move. Explain how the force F, N, and M enables the trailer to move. Remember F, we've been told that it is the frictional force between the trail and the road. And N is the force that is being exerted by the lorry. And the trailer exerts an equal and opposite force M on the lorry. So for these two to move, it means that the resultant force, that is the force exerted by the lorry, and the force exerted by the trailer must be more, it must exceed the frictional force F, so that the two can move. Otherwise, if it does not, it means that the two will not move. Therefore, in this case, we say that the force between N and F causes the motion. Since N is greater than F, it overcomes the frictional force F, therefore enabling the trailer to move. Therefore enabling the trailer to move. So remember from the third Newton's law of motion, we say that action and reaction are equal and opposite. Therefore, the force that is going to be exerted by the lorry is going to result to an equal and opposite force on the trailer. Therefore, the force that we are considering here is the force that is going to make the trailer start moving. Therefore, that force, which is equal to the force that is being exerted by the lorry, it means that for the trailer to move, the force exerted by the lorry on the trailer must be greater than the frictional force. It must be greater than the frictional force F. Therefore, for the trailer to move, it must exert or experience a force greater or larger, than the frictional force. Otherwise, if the frictional force is greater than the force that's going to be exerted by the lorry, therefore it means the lorry will not be able to overcome the frictional force. So for the trailer and the lorry to move, they must exert a force which is going to overcome the frictional force F. The frictional force F. Hoping that we can now understand the relationship between the three forces and how they enable the trailer to move. The second question, the figure below shows a frictionless trolley of mass 2 kg moving with a uniform velocity towards a wall, moving with uniform velocity towards a wall. At the front of the trolley is a spring whose spring constant is 25 newtons per meter. 25 newtons per meter. The trolley comes to rest momentarily after compressing the spring by 3 centimeters and rebounds from the wall. First question, determine the force exerted on the wall by the spring. Determine the force exerted on the wall by the spring. Determine the force exerted by the wall on the spring. So what do we call this force? 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 This force is called, what name given to this force? It is called elastic. It is called elastic potential energy. It's called the elastic potential force, which is given by Ke. It's going to be given by Ke as a result of the extension of the spring. So in this case, from the Hooke's law, we know that F is equals to Ke. From the Hooke's law, we know that F is equal to Ke. And K is the spring constant, and E is, we say that it is extension, but extension can happen in two perspectives. When the spring undergoes compression and when the spring undergoes extension. So both extension and compression are considered to be both compression and stretching. If you stretch a spring or you compress it, both of these perspectives or both of these cases are considered to be extension. So in our case, we have a compression, which is equal to 3 centimeters. Therefore, we consider the compression to be the extension. We consider it to be the extension of the spring. So from the Hooke's law, we know that K is equal to, we know that F is equals to Ke, where K is the spring constant and E is the extension. So in this case, we know we've been told that the spring constant is 25 Newton per meter, and the extension is 3 centimeters. Therefore, we need to convert the extension into meters because we cannot use mixed units here. And it's going to be 0.03 meters. Therefore, the force exerted on the wall by the spring is going to be given by a spring constant 25 multiplied by the extension, which in this case is the compression of the spring, which is 0.03 meters. This is going to give us 0.75 newtons. 0.75 newtons. That is the force that is being exerted on the wall by the spring as a result of the compression of the spring. Then part two, we've been asked to calculate the maximum acceleration of the trolley as it rebounds from the wall. So from the second Newton's law of motion, which says that the rate of change of momentum of a body is directly proportional to the resultant force producing the change, and it takes place in the direction of the force, we know that that can be abbreviated as F, which is the resultant force, is equal to the rate of change of momentum. We know that momentum is given by, it is the product of the mass and its acceleration, which is basically abbreviated as M for mass multiplied by acceleration, which is A. So we've been told to calculate the maximum acceleration from this relationship that F is equal to MA. We can make A the subject of the formula, and in this case, A will be given by force divided by the mass. We know that the force that is acting on the wall, is basically 0.75 newtons. And from the question, we've been told that the mass of the trolley is 2 kilograms. Therefore, the acceleration is going to be given by 0.75 divided by 2, which is 0.375 meters per square seconds. Again, let us remember to indicate the units. As I said earlier, many students lose marks because of carelessness, failing to write their units, the units of the corresponding quantities. So let us move to the next question. This question is asking us to state the reason why the trolley acquires constant velocity after it rebounds. Explain why, or state the reason why the trolley acquires constant velocity as it rebounds. Explain why the trolley acquires constant velocity as it rebounds. Explain why the trolley acquires constant velocity as it rebounds. Explain why the trolley acquires constant velocity as it rebounds. So during rebounding is what is happening is that it is the spring that is in the process of retaining its original shape. It is the spring that is recovering its original length. So the force in the spring decreases as the spring recovered its original length. Remember, we have said that the force that is acting on the wall is as a result of the extension of the spring, which in our case, it was compression. And therefore, for the trolley to rebound back, it means that there will be no extension, or the spring is going back to its original length, or it is recovering, or it is tending to restretch. It's going to be stretched. it's going to go back to its original length or shape. Therefore, it means that there is no force on the trolley. There is no force on the trolley that is going to be lost in the process of the spring regaining or recovering or going back to its original size. Therefore, there is no force that is lost. No force on the trolley after contact with the wall is lost. And therefore, the trolley tends to move with constant velocity because there is no force that is being lost. Because the same force that was felt on the wall is the same force that's going to be used by the spring to recover its original shape or to recover its original size. Therefore, at that time, we say that the trolley acquires constant velocity. The trolley acquires constant velocity. So we only have a few minutes remaining for the class to come to a close. The next question, the figure below shows a smooth surface being pulled by a constant force F. It shows a trolley on a smooth surface that's being pulled by a constant force F. On the axis provided, sketch the velocity time graph for the motion of the trolley. On the grid provided, sketch the velocity time graph of the motion of the trolley. So even before you sketch, you need to ask yourself, what is happening? Is the trolley going to attain constant velocity or constant acceleration, or what is going to happen to the trolley? Remember, we were told that the surface is smooth, and you can see that the trolley is also resting on rollers. Sorry, they look like rollers, but they are wheels. So by the fact that the surface is smooth, it means that there will be no frictional force, or there will be less frictional force. There will be no frictional force, or there will be less frictional force. That is on the trolley. There will be less frictional force. There will be less frictional force on the trolley. And therefore, the velocity time graph will be that of constant velocity. It will be that of constant velocity. Therefore, it is a straight line. It is a straight horizontal line. It's a straight horizontal line. It will be a straight line. Let's go to part 2. A parachute falling through the air attains terminal velocity after a short time. A parachute falling through air attains terminal velocity after a short time. A parachute falling through air attains terminal velocity after a short time. It attains terminal velocity after a short time. Explain. it attains terminal velocity after a short time. Now, even before you explain this question, you need to ask yourself, what is terminal velocity? What is a terminal velocity? And terminal velocity is the maximum speed attainable by an object as it falls through a fluid. In this case, the fluid that we are considering is actually air. Air is an example of a form of a fluid. And therefore, for the parachute to attain the maximum speed as it falls through air, for the parachute to attain its maximum speed as it falls through air, at that particular moment, the upthrust force plus the viscous drag must be equal to the weight of the parachute. The upthrust force which acts upwards and the viscous drag which acts the opposite direction must be equal to the weight of the parachute. I mean, the upthrust force and the viscous drag, both of them act upwards. They must be equal to the downward force, which is the weight which is acting in the downward manner. So at the moment when we say that an object falling through a fluid has attained the terminal velocity or the maximum speed, therefore, this condition must prevail, that the upward forces must be equal to the downward force. The downward force in this case is the weight of the parachute and its content, while the upward forces are the upthrust and the viscous drag. Therefore, the upward forces must be equal to the downward force, and that is upthrust plus the viscous drag must be equal to weight. So what happens is that viscosity is going to increase downwards, and after some time, weight is going to be equal to the sum of the upward forces. That is why I'm saying that for a body to attain terminal velocity, then the upward forces must be equal to the downward forces. The upward forces must be equal to the downward forces. The upward forces must be equal to the downward forces. Upward forces must be equal to the downward forces. For any body that is falling, then the upward forces must be equal to the downward forces. Mr. Washira, I don't know whether I can continue or should I end here? Mr. Washira, are you there? Mr. Washira.
Yes.
Mr. Washira, can you hear me?
Yeah, I can hear you.
Can I continue or I end the class?
You can continue maybe up to 40.
Up to?
40 or 45. Then you can end the class from there.
Okay, thank you. So I hope we can now understand what causes a body or what makes a body to attain its terminal velocity. We have said that the upward forces must be equal to the downward forces. In this case, the downward force is the weight of the body as a result of its mass and the gravitational pull, or the gravitational force, that is W is equals to mg, which results to the downward force called weight. Then the upward forces are the upthrust due to the fluid and the viscous drag due to the fluid, where both of them act upwards. Therefore, at the time when the sum of the upward forces is equal to the sum of the downward force, at that time, we say that the body has achieved its terminal velocity. So the next question, we have a horizontal force F 12 newtons is applied on a wooden block of mass 2 kilograms placed on a horizontal surface. It causes the block to accelerate at 5 meters per second, per square seconds. Determine the frictional force between the block and the surface. Determine the frictional force between the block and the surface. Determine the frictional force between the block and the surface. So the frictional force between the block and the surface is going to be given by the difference between the net force or the force applied minus the accelerating force is going to be given by the force applied, or the difference between the net force and the force that is causing the acceleration, the force that is going to cause the acceleration. Because for the acceleration to take place, there must be a certain force that is going to overcome the frictional force for this particular motion to take place. For this particular motion to take place, the net force must be greater than the frictional force. So in this case, we are told that the body is being given a horizontal force of 12 newtons. And therefore, this force is the force that is being applied on the body. That is the wooden block. But the force that is going to cause the acceleration from the second Newton's law of motion, we know that F is equal to ma. Therefore, the force that is going to cause this motion is actually the force as a result of the rate of change of momentum. We know that the rate of change of momentum is directly proportional to the force or the resultant force. Therefore, there are two forces here. There is the force that you're going to apply on the wooden block, and there is the force that is going to cause the motion, what we call the accelerating force. And therefore, the force that is applied must overcome the frictional force between the wooden block and the surface. It must be able to overcome the frictional force between the surface and the block. And therefore, the force that is going to be used, or the force required to cause an acceleration, will be much less compared to the force applied. Why are we saying this? This is basically because it must overcome the frictional force. And therefore, the frictional force, or the magnitude of the frictional force, is going to be given by the difference between the force applied, the difference between the force applied and the force that is going to cause the acceleration, or the magnitude of the force that is going to be used in the process of making the body to move. That is what we call the accelerating force. So in this case, we know that the force applied is 12 newtons, and the accelerating force is going to be obtained from the second Newton's law of motion, that is F is equals to ma, where we know that the mass of the block is 2 kilograms multiplied by the acceleration of the block, which is 5 meter per square seconds. Therefore, the accelerating force is going to be 2 times 5, which is 10 meters per square seconds. 2 times 10 meters per square seconds. Therefore, the accelerating force is actually 10 newtons. The accelerating force is 10 newtons. Therefore, you can see that the accelerating force is less than the force applied, meaning that there is some form of energy that was lost to overcome the frictional force. And this energy is the one that we are saying that it is actually the frictional force itself. Therefore, to get the frictional force, we need the force applied, which is 12 newtons, minus 10 newtons. This is going to give us 2 newtons, which is the frictional force between the block and the surface. I wish to add there. Once again, I want to take this opportunity to thank you for attendance and also for your patience as we do our revision. Kindly go through your assignment. Assignment is going to form 80% of the opener exam. Take it seriously. I wish you all the best as you continue to enjoy your holiday. We meet next week as the school opens. Have a good day.